Hi, this is our final project by Jenna, Claire, Lauren, and Venus, and our topic was the effects of the increased precipitation on Virginia's Chesapeake Bay watershed. Our table of contents includes climate effects, effects on communities, water quality, marine life, and our concept map, as well as possible solutions and actions that are being done.
The first topic is climate effects. Climate effects and increased precipitation. Global warming. Rising global temperatures can lead to increased evaporation, resulting in more moisture in the atmosphere and subsequently more precipitation. Natural climate variability. Natural climate patterns such as El Nino and La Nina can cause shifts in weather patterns and result in changes in precipitation levels. Changes in atmospheric circulation patterns. Changes in wind patterns and atmospheric circulation can affect the distribution and intensity of precipitation. The picture on the side shows the total annual precipitation in the Chesapeake Bay watershed since 1901 to the year 2021. Increased moisture in the content in the atmosphere. Warmer air can hold more moisture, leading to increased rainfall when conditions are favorable for precipitation. Changes in land use and urbanization. Urban areas often have more impervious surfaces such as concrete, which can alter the natural water cycle and result in increased runoff and localized precipitation. Influence of weather systems and storms. Variations in the frequency and intensity of weather systems, such as frontal systems and tropical storms, can contribute to changes in the precipitation patterns. The picture on the side shows the geographical scale of the Chesapeake Bay area and how it might affect the increase in precipitation in the region.
For the first topic was the effects on communities. Increase of precipitation. The increase in precipitation could be catastrophic since it would increase the water flow as it goes down the river, washing away all good topsoil and causing an unstable land for the communities close to the waters. Global warming. As storms and soil runoff cause aquatic and terrestrial life to diminish on the banks of our waterways, we begin to see erosion take hold that results in land loss. As these barriers die and recede, the roots biodegrade and can no longer support the beach or bank, causing further land loss. With the loss of land and thereby vegetation, we can lose vital carbon dioxide depending plants, which leaves more carbon dioxide in the atmosphere to further perpetuate global warming. Loss of stable land. The homes just off the edge of the embankment are at risk of becoming part of the sea in our lifetime. Whether through erosion or sea level rise, both are interconnected. Land loss presents a twofold problem for humans and our survival. Sea level rise is combined with global warming, and global warming is a consequence of refining and burning fossil fuels, deforestation, and overdevelopment.
Next, we'll talk about how the increased precipitation affects the water quality of the Chesapeake Bay. The increased precipitation impacts on nutrient levels causes nutrient runoff. Sources of nutrient runoff due to the increased precipitation can be heavily found in the Hampton Roads area, which has a population of almost 2 million. Sources of where these nutrients come from may be from golf courses, large-scale agricultural, residential homes, and industrial areas that use chemicals and fertilizers that seep into our waterways. Nitrogen and phosphorus roles in the water community. Almost over 491 million pounds of nitrogen was delivered to the Chesapeake Bay between October 2018 and September 2019. These can cause harmful algae blooms, which nitrates and ammonium can stimulate the growth of harmful algae species. 34.8 million pounds of phosphorus was delivered to the Chesapeake Bay between October 2018 and September 2019. This can cause eutrophication, which is excess of phosphorus or phosphates. It is a process in which excess nutrients stimulate the overgrowth of algae and other aquatic plants. Algae blooms can disrupt the balance of the ecosystem. Here are the levels of the nitrogen and phosphorus between 2000 and 2020. The impacts of salinity levels at the mouth of the bay. Salinity differences contribute to the stratification of water layers, particularly in the deeper channels of the bay. Stratification can influence oxygen levels, with lower oxygen concentrations often occurring in deep, more saline layers. This can lead to the formation of hypoxic, low oxygen, or anoxic, absence of oxygen zones, which can be detrimental to fish and other aquatic organisms. Salinity at the mouth of the bay averages between 25 to 30 ppt, and at the head of the mouth it is less than 0.5 ppt. During large rain events, salinity levels decrease, which dilutes the salt in the sea water. Drastic changes in salinity can have severe consequences for a bay's underwater life, such as oysters require salty water, and they can't move if conditions changes. They close their shells, but only for a short period before they begin to suffer. Another consequence is that underwater grass would not be able to migrate. Estuarine circulation. Salinity variations drive estuarine circulation patterns, influencing the movement of water and the transport of nutrients and sediments. Changes in salinity can alter the strength of these currents, affecting the overall ecosystem dynamics. The estuarine circulation of the Chesapeake Bay consists of two-layer flow, with the upper layer discharging low salinity water onto the continental shelf, while the lower layer draws higher salinity shelf water into the bay.
Finally, we're going to discuss how increased precipitation affects marine life living in the Chesapeake Bay. In the Chesapeake Bay, we have over 3,600 species of animals and plants. Among those, there are around 350 varieties of fish, 4 kinds of sea turtles, and hundreds of invertebrates, oysters, and birds. The main issues facing marine life living in the bay are algae blooms, sediment runoff, and litter runoff. The first of the three, algae blooms, create dead zones that are harmful for fish, shellfish, and other underwater life. Their growth on the top of water blocks light to organisms. The second, sediment runoff, makes water murky and makes sunlight harder to reach aquatic plants and animals, destroys habitats. Litter runoff smothers aquatic plants and bottom-dwelling organisms and adds toxic contaminants to the water and makes animals sick. Two specific examples of marine life facing issues in the bay are blue crabs and bass. Blue crabs face harmful environmental conditions including water quality, weather patterns, and loss of habitat that causes the abundance of blue crabs to fluctuate from year to year. Bass deal with low dissolved oxygen in deeper bay waters, which has eliminated much of their summer habitat. They also face acidity and chemical contaminants in certain spawning areas. Bass also have to deal with poor water quality from runoff from the land and sewage treatment practices.
And here's our concept map on the topic. Actions been done today. Living shoreline, which can be found in Birdsong Wetlands, Norfolk, Virginia. replacing concrete and debris with native wetlands, which can be found in Collie Bank, Norfolk, Virginia. Tidal marsh restoration and oyster reef proves habitat-based resiliency can be found in Money Point, Chesapeake Bay in Virginia. Rain gardens and wetlands, which can be found in Paul Burbank Elementary, Hampton in Virginia.
Possible solutions and next steps. Improve infrastructure. Enhancing drainage systems, constructing flood barriers, and implementing green infrastructure can help manage excess water and reduce flood risk. Public awareness and education. Promoting awareness about the impacts of increased precipitation and providing information on adaptation strategies can empower individuals and communities to take proactive measures. Community engagement. Encouraging community participation and involvement in decision-making processes such as flood risk management and adaptation planning can foster local ownership and enhance the effectiveness of adaptation efforts.